today, in this chapter, we'll be looking at a couple of things. The first of which is basically ionic compounds and how they are formed and how do we name them. All right, that's the first part. The second part will deal with some other topics which we'll get into later on. So let's start with talking about elements and ions. And I think we discussed elements already. Elements, we said, were substances that cannot be broken down into anything simpler chemically. All right, and in terms of how we represent them in chemistry in a shorthand fashion, we use their symbols. The symbols can be found, of course, in the periodic table, and these are just a few examples of different elements and their symbols, right? And you'll see that in some cases one can see the obvious relationship between the symbol and the name, but in other cases it's not so obvious. And the main reason for that is because the situations where, for example, the symbol is different from the name, like in the case of sodium, is because of some Latin origin associated with the name of the elements before we have our English version. All right, so these are the symbols for these different elements, and then there are certain elements that exist as diatomic elements. In other words, each molecule has 2 atoms, and these are the 7 elements that are as such. You have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So whenever you see a question where these elements are involved in a reaction by themselves, then you need to remember that they exist as diatomics, right? And then you have some other elements that exist as polyatomics, namely sulfur and phosphorus. Sulfur exists as 8 atoms per molecule, and phosphorus exists as 4 atoms per molecule. Okay, so with that out of the way, let's get into a discussion of ions, which is the main heart of what we'll be discussing today. So an ion is basically a charged particle that can be produced by removing or adding an electron, one or more electrons actually, from a neutral atom. Okay, so that's basically what we mean by this term ions, all right? And as stated here, ions can be produced by either adding or removing electrons from a neutral atom, such as in the case of the potassium atom, right? So the potassium atom, potassium has an atomic number of 19, and therefore in the neutral atom, you have 19 protons in the nucleus and 19 electrons surrounding the nucleus, all right? So that's a neutral atom. Now, if you were to remove 1 electron from this structure, right, then you're going to end up with a situation where you have 1 more proton compared to the number of electrons remaining, right? The result of that is that the resulting species, which is now an ion, will have an overall +1 charge because you have 19 positive charges, 18 negative charges, so 19 minus 18 gives you +1. So therefore, we call this the potassium ion. And generally speaking, species that have a positive charge associated with them, we call them cations, all right? So cations are basically positive ions, all right? So that's what happens in the case of sodium, in the case of potassium. When you remove an electron, you're going to end up with the potassium ion, which has a +1 charge. So as stated here, if you have a structure where 1 or more electrons are removed, then the positive ion is formed, and that positive ion is called a cation. Okay, so there are some other examples we can look at. For example, sodium can also lose 1 electron to form the sodium ion. Calcium will lose 2 electrons to form the calcium ion, which is Ca2+, and aluminum will lose 3 electrons to form the aluminum ion. So you'll notice a pattern here based on these equations, right? For every electron lost, there's a positive charge that remains on the remaining structure, all right? So 1 electron is lost by the sodium atom, so therefore the resulting ion has a +1 charge. 2 electrons are lost from the calcium atom, so therefore the remaining ion will have a +2 charge, and 3 electrons will be lost by the aluminum atom to form the aluminum ion, which has a +3 charge, right? So basically, whatever the number of electrons that are being removed, then the number of charges would be the same. The number of positive charges would be the same remaining on the cation that is formed, all right? So this begs the question, how do you know the correct number of electrons that will be lost? And I won't get into that answer right now, excepting to say that it is in part dependent on the position of the element in the periodic table. So basically what I'm saying here, that if you look at the elements in the periodic table, depending on the region, you'll see that, for example, sodium is in group 1A, all right, or group 1. So therefore, it will lose 1 electrons to form the sodium ion. And this is true not only for sodium, but true for other elements in that group, such as hydrogen, lithium, sodium, which is the one that we were just talking about, and potassium, and if I'm not mistaken, rubidium is also in group 1. So all these elements here basically behave the same way in that they tend to lose an electron to form a +1 charge on the remaining ion. In the case of calcium, calcium belongs to group 2A. All right? And the elements in group 2A include, well, helium is a bit of an exception. So I'm going to put an asterisk here. But the other elements, well, helium actually is said to be noble gases. So technically speaking, it's not in group 2A. But you have, what elements do you have in calcium? You have beryllium. You have calcium, and there's another element which I can't recall right now. Let me do a quick look up here. Oh, how could I forget? Magnesium. All right. Strontium is another element in group 2A, and barium, right? And these elements behave similarly in that the atoms will lose 2 electrons to form an ion with a +2 charge. And then we get to aluminum. And in the case of aluminum, which belongs to group 3A, they will tend to lose 3 electrons for each aluminum atom. And that is true not only for aluminum, but for other elements such as gallium and indium and others in that group, right? So there is some correlation between the position of the elements in the periodic table and the number of electrons that will be lost by the particular atom of that element, all right? But it's a bit more complex than that. I mean, that is generally true for the first 20 elements, but when you get beyond the first 20 elements, then things are a bit more disordered and confusing, and therefore we cannot just simply look at just the group numbers to make a prediction as to how many electrons will be lost. Okay, so with that said, let's move on to how do we name cations. And it's very easy to name cations. It's basically this rule that you have to follow. Cations are named the same as their parent atoms. So whatever the name of the element is, the name of the cation will be the same. All right, so for example, in the case of sodium, it forms a sodium cation, which is Na+. So the name of this particular cation is the sodium ion. The same is true for calcium. The calcium ion is called, or I should say the Ca2+ ion is called the calcium ion. The Li+ ion is called the lithium ion. The Mg2+ ion is called the magnesium ion. So basically whatever the name of the atom that the ion is formed from, that's the same as the name of the cation. Okay, now we're going to stop here, and then the next video we'll be looking at anions, which are basically the opposite of cations. All right, until next time.